Yes, is this audible? Khalid, Salman. So in the last class, we had started with terminal potential difference, EMF, and internal resistance. So internal resistance was what? Internal resistance was basically the resistance that was offered by the electrodes and the electrolytic solution. Then we had seen EMF. It was the maximum potential difference across the terminals of a cell in an open circuit. Terminal potential difference distinguishes it from by being the potential difference across the terminals of the cell in a closed circuit. So it's the potential difference across the resistor, external resistor that is connected. Formula of current is E divided by capital R plus small r. V is this I multiplied by capital R, means the potential difference across the external resistor. Terminal potential difference formula is V is equal to E minus I small r. Now, one just point that was left in here, it was when you have the current flowing in this manner. This is the resistor connected, this is the EMF of the cell, and in this manner current is coming out of the cell. The whole current, this is coming out of the cell in this manner through this internal resistor. We call it cell is getting discharged. So this is known as cell discharging of cell. This we call it as discharging of a cell whenever current is moving out of it. Moving out of it means what? Going out through the battery. This is called discharging, and the formula of discharging is only E minus IR. V is equal to E minus IR. The formula that we had written, this formula is that only discharging case. But instead, if it is charging, for example, if it is in this manner, small r is there, this is the EMF. Current is going into the cell, means current is moving out from the negative terminal of the cell in this manner. Then V becomes E plus IR. This is called charging of cell. And if somewhat your key is open, if your key is open, mean your circuit has been broken. So current won't be there in the circuit because no connection, proper connection is not there. So current will be 0, and when current will be 0, V will directly be equal to E. Means potential will be equal to the EMF. So terminal potential difference equals to the EMF of the cell, in which case when the circuit is an open circuit, key is open. So that current becomes 0 and the terminal potential difference becomes equal to the EMF of the cell. So these 3 points were just left in here. Then we'll begin with a new topic, combination of resistances. So resistor capacitors combination we have already done. We'll be doing it. We'll repeat it for resistors. So just note down these 3 points. And what about the assignments? Did you receive the assignment this time? The assignment of this topic, internal resistance and EMF, this topic. Did you receive it, Salman? Khalid, what about you? Did you receive the assignment?
I didn't check.
Ma'am, the EMF one, EMF and internal
This one. Did you receive it?
Yeah, yes, ma'am.
So do it and submit it by the next class so that we can discuss it.
Yeah, okay.
Done? Have you people written it?
Yes, ma'am.
Written these 3 points?
Yeah.
Or
Yes,
now,
sir.
okay, the next topic that you have is the series and parallel combination. But before moving into what we have already studied in capacitance, if you are given the series combination of cells of these only, means these various internal resistance cells are connected. This is having E1 EMF, R1 is the internal resistance. Then second cell is there, E2 cell is there with internal resistance R2. Similarly, E3 is there with internal resistance R3 in this manner. And external resistor capital R is connected. This is the circuit that you have. Now, if you are asked to calculate the equivalent EMF, means net EMF, then just add it directly, E1 plus E2 plus E3 in this manner. E equivalent, it will be E1 plus E2 plus E3 up till En if n number is connected. If you are asked to calculate the equivalent resistance, means internal resistance. Equivalent internal resistance, then also add all the internal resistance. R1 plus R2 plus R3. If all the cells are connected in this manner, then equivalent internal resistance will be this. Now, if you are asked to write the current was what? E divided by capital R plus small r. So in this case, I will be equal to what? I will be equal to E equivalent, means this, divided by capital R plus small r equivalent. It's basically you have to add them and then put it in the formula that you have. I'll give you a question also on this. Let's practice a question on this.
Ma'am, in the question, we have to find only two things.
Yes, only two things. First, note down these points, then you can solve this question. Current through each cell, and then the terminal potential difference across 10 volt. Means this. See, in this question, E equivalent will be what? E equivalent will be sum of all the EMFs that you have. If you calculate the E equivalent means equivalent EMF. Equivalent EMF. So it will be directly the sum of all EMFs. So that is 10 volt plus 5 volt plus 15 volt. That makes it 30 volt. And then also R equivalent means equivalent internal resistance. Sum of all the internal resistance that you have, that is 1 plus 2 plus 2. So that is 5. And capital R is already given as 10 ohm. This is capital R. So current is what? Current is E equivalent divided by R plus small r equivalent. Now here you have to put in the values that you have seen. I is what? I is equivalent, that is 30 volt. Capital R is 10, small r is 5. That makes us 30 divided by 15, that is 2 ampere. This is the answer for the first part. Now the answer for the second part. Second part is asking you the terminal potential difference across 10 volt. Across 10 volt means terminal potential difference of this. This is the question. So you have EMF with you as 10 volt. You have R with you as 1 ohm. So terminal potential difference formula is what? E minus IR. E is 10 volt. I you have calculated in the first part 2 amperes. Small r is 1 ohm. So when you put V will be, this will be 10 minus 2 into 1. So V will directly be 8 volt. And I current is 2 amperes. Note down the solution. add one more node point. See, in this, all the cells were connected in the same direction. What if I reverse a cell? For example, I have reversed this, and it is means negative terminal is connected to the negative terminal. Let's add a resistance also in between. This is the EMF1, R1. This is E2 with its resistor, and E3 with its resistor R3. So see, both these are connected, but this is connected in which manner? Opposite manner. Here you have the negative terminal connected to the negative terminal and the positive terminal getting connected to the positive terminal. Means E2 is reversed, and then this is the rest of the circuit. If you get such a case, when you are calculating equivalent, no, then don't add it directly. Whichever cell is reversed, just add a negative sign. For example, E1, E3. But for E2, add a negative sign, minus E2, then plus E3, because this is reversed. And for R equivalent, still add all of them. Resistance can never be negative. So that's why we keep on adding all these. R1 plus R2 plus R3. Just make a note point and add this. The rest of the terms will be the same. R plus small r. Now we have the series combination. Separately, we'll do say series combination and parallel combination the way we had done it for capacitance. So in case of resistors, you have in series combination that current through each resistor current through each resistor, this is same while the voltage divides. So in case of capacitor, you were having charge through the each of the resistors, each of the capacitor could remain the same and the potential was again getting divided. So in case of resistors, you have current that is remaining same through the each resistor and the voltage that gets divided. Now, if I say this is R equivalent, this is the potential difference V, and I current is flowing across this circuit in this manner. This is current I flowing through it. Now, total potential difference. This is V, capital V. Total potential difference, it will be what? V1 plus V2. Let's say there are so many resistors connected up till Vn. Now, V is equal to, according to Ohm's law, V is equal to IR. So, V can be written as IR equivalent. V1 can be written as IR1. V2 can be written as IR2. Vn can be written as I will remain same, IRN. This will be the resistor. See, current will get cancelled from all of them. R equivalent will be what? R1 plus R2 up till Rn. So in case of series combination, you just directly have to add all the resistances. While in case of capacitors, we had seen the potential remained the same. So Q by C got us 1 by C equivalent as 1 by C1 plus 1 by C2 plus 1 by Cn. In case of series combination of resistors, you have all the resistors getting added together. Resistances are getting added. Now, if you have to find current through each resistor, if you have to find current through each resistor, so I1 will be equal to I2 will be equal to IN, which is V divided by R equivalent. Means whatever is the voltage of the circuit, just divided by the R equivalent that you are getting from here. And then you can also be asked to calculate the voltage across each resistor, similar to current across each resistor. So it will be what? Voltage through each resistor or voltage across each resistor. V1 will be simply IR1. V2 will also be IR2. Yeah. Current will be remaining the same. Current will be the same, but resistors are different. So R1, R2. So even if it is N, so Vn will be IRN. This will be the voltage across it. Then you can also get to you can be asked to calculate the power across each. So power that is dissipated across each resistor. See, P is equal to I square R. The relation between power, current, and resistance. This is P is equal to I square R, sorry, not IR square, I square R. This is the relation between power, current, and resistance. So if this is given, P1 is there, I square R1 will be there, I will be the same. P2 will be there, so it will become I square R2. Similarly, Pn will be there, it will be I square Rn. I will remain the same because this is series connection. So if you are asked to write the total power that is dissipated, this is across each one, no. If you are asked to write the total power, that will be P1 plus P2 up till Pn. Or you can also write it as P is equal to I square R equivalent. Because see, I square can be taken as common and R1 plus R2 plus Rn is what? This is resistance, equivalent resistance. So do one thing, note down all these points, then we will do a question on the series combination. Shravya, do that assignment also. That one I've seen yours. I'll discuss it in the next class. Shravya, that assignment, internal resistance. And you received, no? That. All right, all right. That also you submitted in the next class, then we'll discuss it. Also, you all have a very short subjective test on the topic capacitance. So in the next class, when we have the next class on Wednesday, we have it. So on Wednesday, we'll be having a very short test on the topic capacitance. All right, Salman.
Ma'am, please scroll up for series combination.
This we had done before, you came.
Ma'am, I'll take screenshot.
All right, take the screenshots. Done? Should I scroll?
Ma'am,
And this was the last topic before you came.
done.
Now all of you try these parts. Series equivalent resistance is very easy. And you have to calculate the total voltage across it. See, this is 10 ohm, this is 5 ohm, this is 10 volt. Series combination, you have to add directly R1 plus R2. Yes, that's correct. Calculate rest of the parts also. Total voltage, total current, voltage across each and current across each. Yes, first part is correct. R equivalent will be 15. Second is also right. Yes, third will be 2 by 3 amperes. Let's discuss it then. See, the first part, this is easy. R equivalent will be what? Voltage across each 10 by 3, 20 by 3, correct. Third answer, Shravya, is 2 by 3. See, second answer is also easy, Shravya. Total voltage means whatever voltage is given. Voltage that is given to you is 10 volt. Let's discuss the first part first. R equivalent will be simply R1 plus R2. So that is 5 plus 10, that gives 15. Voltage means total voltage that is given, 10 volt in the circuit that is given. Yes, 2 will be 10 volt. Fifth part, yes, all the parts are correct. Correct. So third answer, you have to find out the total current. So total current will be what? Total current will be V divided by R equivalent. Voltage is 10, R equivalent is 15. So if you reduce it, current will be what? Current will be 2 by 3 amperes. This will be the current. And since it's series combination, current will across each will remain the same. Now the fourth part was what? Voltage across each. So V1 will be IR1, V2 will be IR2. So I is what? 2 by 3, R1 is 5. So this will be 10 by 3 volts. V2 will be IR2. So this will be 2 by 3 into 10. That is 20 by 3 voltage. If you add, you can add and check. See, 10 by 3 plus 20 by 3 gives you what? 30 by 3, that is 10 volt. So you're getting the total voltage back. And since it's a series combination, I2 will be equal to I1, which will be equal to I, that is 2 by 3 amperes. All right, noted down, then we'll do parallel combination. See, in this parallel combination, this is similar to the one that we have seen in capacitance. So in case of capacitance, we had seen that charge got divided in case of parallel and voltage remained the same. Similarly, in case of parallel combination of resistors, voltage will be the same, but current will divide. So here voltage remains same, but current divides. Reason is that current divides on branching. So current gets divided. Current divides. Now, if you have R equivalent, this is V and this is I. So in this case, which quantity will remain the same? In case of parallel combination, your current remains the same. So current will be what? Current will be I1 plus I2. Let's say n number of resistors are connected in parallel. So it will be what? IN. So V is equal to IR. So I will be what? I will be equal to V by R. So here we have V divided by R equivalent, V divided by R1 plus V divided by R2 up till V divided by Rn. All the voltages get cancelled. Equivalent resistance that you get 1 by R equivalent. This will be 1 by R1 plus 1 by R2 up till 1 by Rn. This is the formula of resistance. Now, voltage will be the same, but we can have different values of current across each resistors. So, current through each. I1 will be V1 by R1. I2 will be V2 by R2. Similarly, IN means across anyone will be V by Rn. Not V1, V2 here because V is the same. So even if we write it as V1 and V2, voltage will be the same. So note down these things. We'll do a question on this as well. That will be 1 by R equivalent. No, R equivalent you have to tell. Yes, yes, Salman, right. Yes, it will be this, the reciprocal of it. Correct, Shab. Second part is right, Shravya and Salman. Third part, okay, good, good. Salman, third part is also right. Also add the units, ampere and volt.
Yeah. Okay.
Now, first, second, third part are correct, Khalid. Yes, right. 10 by 3, 10 and see, first part is easy. First part you have to calculate. Yes, fourth is also right, Khalid. Try the last part as well. This is which answer you sent? Fourth one. Fourth one was, yes, fourth one is right. Yes, Shavya, third one is correct. Try the last part as well, Khalid. See, first part will be what? 1 by R equivalent. This will be 1 by 5 plus 1 by 10. So that will be what? 1 by R equivalent. This becomes fourth part's answer. Yes, yes, correct. Last part is left. Try the last part as well. So this will be 10, 2 plus 1. That gives 3 by 10. So R equivalent will be what? 10 by 3 ohms. I1 is coming 2 amperes and I2 good, good, correct, Khalid. All the parts are right. Second part is what? Total voltage. So total voltage is given 10 volt. Then the third part was asking you the current. So if you have the resistance and voltage, you can easily calculate the current from here. So 10, 10 gets cancelled. You have 3 ampere. I1 is right. So what will be I2? Good, good, good. I2 is also correct. So all the parts have been answered by you and Khalid both. Fourth one, yes, yes, Salman, right? Fourth one will be 10 volt. V1 is equal to V2 because it's a parallel combination. No need to solve it. Last part, I1 will be what? It will be V1 by R1. I2 will be what? V2 by R2. So I1 will be V is what? 10. R1 is 5. This will be 2 amperes. I2 is what? 10. R2 is what? This was 10. So that makes it 1 ampere. I1 is 2 ampere. I2 is 1 ampere. Good. So all of you have done all the parts correctly. So I'm not doing the next topic. Only one that case is left, infinitely connected resistors, if infinite resistors are connected. So that I'll discuss in the next class because many students were having their exam today.